All right, welcome back, 8th graders. Yesterday, you should have completed part 1 of the thermal energy review. If you guys haven't done that yet, you need to go back and do that. Maybe you guys got partially done and you need to finish, or maybe you guys just haven't started. You were gone yesterday, whatever the reason. Part 1 needs to get done first. Okay, so then once you guys are done with part 1, you guys can continue on with part 2. So for part 2, we're going to really focus on energy transfer. So the first 3 or 6 slides, really the first 3 problems we're going to look at 2 different molecules that have varying thermal energies, kinetic energies, average kinetic energies, numbers of molecule sizes, stuff like that, and then what happens when they're pushed together and they're allowed to transfer energy until equilibrium is reached. All right, so the first one, and really on these guys, I suggest you guys get something to do this on. If you guys are working at home, grab a piece of paper and draw these out. They're really hard to visualize and to remember what's going on if you guys don't have them sitting in front of you, okay? If you guys are sitting in class right now, you guys can go grab a marker board on the side counter by the door, and you guys can draw these out, and you guys can either do like little X's to represent your energy cubes, or if you guys want, on the back table back here, I left some cups out of energy cubes that you guys can come grab those energy cubes. There should be 32 in a cup, so double check that first, and you guys should be using all 32. Okay, with that being said, grab something to help you guys visualize these, otherwise it's going to be really hard. So first one, sample A contains 4 molecules, so you guys would draw sample A and then draw 4 circles to represent each molecule in sample A, each with an average kinetic energy of 15 kilojoules, meaning that each of those molecules have 15 kilojoules. So if you guys are drawing this out, maybe you guys draw 15 little X's in each of those circles, or you write the number 15 in each of those circles, or if you guys are using the energy cube, count out 15 kilojoules in each of those circles. Okay, for this one, you guys might need more than the 32 in the cup. You're more than welcome to grab what you guys need. Okay, sample B has the same size, so 4 molecules as well, but has an average kinetic energy of 11 kilojoules. So you guys would either do 11 X's in each of the 4 molecules of sample B, or 11 energy cubes, whatever the case. Okay. Which sample would have a higher temperature? So for on these first questions, if you guys end up getting the same, if you guys think they have the same temperature, you guys need to write same over them like this. Okay, so same wasn't an option for you guys on here, but that doesn't mean it's not an option for you guys' answer. So kind of little trick question there for you guys. But for this one, it's not going to be the same, so I'll go ahead and give you guys that hint as well. Same with this one, in which sample are the molecules moving the fastest? If you guys think they're moving the same and that sample A isn't moving faster or slower than sample B, you guys just go ahead and write same right over the top. Okay, otherwise you guys are highlighting either sample A or sample B, so same with part 2, please use a bright color like this pink or an orange to highlight either sample A or sample B for these. All right, so moving on to the next one. If we looked at only one molecule, so look at one of your circles or one of your molecules in sample A, what would be its kinetic energy? How many little energy cubes or X's, or what's the number written in there for your average kinetic energy? Okay, same with sample B. Look at one molecule, what's its average kinetic energy? And then what is the thermal energy of sample A and the thermal energy of sample B? Remember that thermal energy is the total energy. So if we have 4 molecules in sample A, each with an average kinetic energy of 15, we would take 15 plus 15 is 30, plus 15 is 45, plus another 15 is 60. So your total kinetic energy, or your thermal energy for sample A, would be 60. Okay, same with sample B. Add up all of those kinetic energies in the 4 molecules for sample B, and that's going to be your guys' thermal energy. All right, now we're going to assume that sample A and B are moved together. They are now in contact, and energy can transfer between those molecules. So remember, energy is going to transfer until all of the molecules, all 8 in this case, have the exact same average kinetic energy. So the same number of energy cubes, or the same number written in them, or the same number of X's, whatever you guys chose to do. Okay, remember that energy always transfers from the warmer object to the colder object. Okay, so which one is your warmer object? Which one's your colder object? Which direction is energy going to transfer there? You guys can either highlight or circle sample A to B, sample B to A, or no energy transfer at all. So meaning that they're the same temperature, they're the same average kinetic energy, so there's going to be no movement of energy there. Okay, so circle which one you guys think is correct. And then what would be at equilibrium? The average kinetic energy of sample A. So if you looked at one molecule in sample A at equilibrium, what would be its average kinetic energy? Hint for you guys, it should be the same as this right here. What would be the average kinetic energy of sample B? If you have different answers here, you're not at equilibrium. You guys got to keep moving some of your energy cubes around. Okay, and then what will be the final thermal energy of sample A and sample B? So because these two are the same size and we've made them come to equilibrium, they should have the same thermal energy or total kinetic energy. Okay, this is the only situation which that's going to happen, because the next two examples I give you guys, they won't be the same size. They won't be 4 molecules each. So you guys should get the same answer for both this one and this one. Remember, you guys are adding up the total kinetic energy there. All right, new example. So we got sample C contains 2 molecules each with an average kinetic energy of 1 kilojoule, whereas sample D contains 8 molecules each with an average kinetic energy of 6 kilojoules. So for sample C, draw 2 molecules, add in 1 kilojoule of energy to each of those. Okay, sample D, draw 8 molecules, so 8 circles, and then add in 6 to each of those. Okay, and then answer these questions here, which would have a lower sample or temperature, either sample C or sample D. Remember, if they have the same, you guys can write same here. Okay, in which sample are the molecules moving the slowest? If they're the same, write same. Otherwise, highlight either sample C or sample D for both of those questions. Okay, if we looked at only one molecule of sample C and D, what would be their kinetic energies? And then what are the thermal energy of sample C and sample D? So remember, add all of those kinetic energies up for those. All right, if sample C and D came into contact with each other and were allowed to reach equilibrium, so remember, at equilibrium, they should have the exact same kinetic energy for each of the molecules. So you should have the same answer here. But are we going to transfer from C to D, D to C, or no energy transfer at all? Remember, we're moving our energy from the higher energy, or to the cooler or the lower energy. Okay, and then last two questions, what would be the final thermal energy of C at equilibrium or D at equilibrium? Hint for you guys, these two answers on this C and D sample will not be the same, because sample D is much bigger than sample C. Okay, so you guys will not have the same thermal energy on sample C and D on this one like you did on the last one. All right, last little example of this here. Sample X has 3 molecules, so draw 3 circles, with an average kinetic energy of 2 kilojoules. Sample Z contains 6 molecules, each with an average kinetic energy of 2 kilojoules. So which sample would have the same the higher temperature? Sample X, sample Z, or if they're the same, write the same. In which sample are the molecules moving the fastest, X or Z? And if they're the same, write the same. If we looked at one molecule of sample X, what would be its kinetic energy? Same with Z. And then what are the thermal energies of X and Z? Again, if we were to push those together and allow them to reach equilibrium, which ones are hotter objects? So which direction is our energy moving? What would be the average kinetic energy? As with the other two, these should be equal to each other. Okay, we're at equilibrium, so they should be equal. But on these last two, they are not the same size, so you will not have the same total kinetic energy or thermal energy. All right, finally, moving on, just some vocab. Which way does energy transfer in a system? I just said that about 3 times. What is equilibrium? You guys should know this from your notes. And again, I referred to it quite a bit there in the last couple examples. And then what is heat? Okay, so if you guys need to, go back to the energy demos that we did at the beginning of this unit and watch some of those YouTube videos that explain heat for you guys. All right, and then finally, we have this same example that we talked about from the thermal energy unit that you guys need to be able to explain to me this phenomenon. So a metal hard drive and a book are left out in the sun for 3 hours on a 100-degree Fahrenheit summer day. So true or false, they are the same temperature, yes or no? So highlight either true or false there. Okay, there is no in between on that one. And then when you place your hand on the hard drive or the book, describe which way the energy is moving. So think about the temperature of the hard drive and the book, and then the temperature of your hand, which is hotter, which is colder, which way is energy going to move. To the touch, which feels hotter, aka which has more heat. And then why does it feel hotter even though they've been in the same conditions for the last 3 hours? Okay, same scenario there, except we're looking at a metal hard drive and a book out at 0 degrees Celsius in the freezer for 8 hours. So true or false, the book and the hard drive have the same temperature, so circle one of those. And then when you place your hand on the hard drive or the book, describe which way the energy is moving and why. So which is hotter, your hand or the book/hard drive. And then to the touch, which feels colder. So if you touch the book and the hard drive, which one's going to feel colder to you guys? Why does this feel colder even though they've been in the same conditions for the last 3 hours? So again, revisit what you guys need to. You need to go back to that thermal energy demo and watch some of those YouTube videos. The 2 about misconceptions are the ones you guys probably want to be in for that. Okay, finally, do your wrap up. Do you have any questions, yes or no? If yes, please type them below. If you guys need help on this, let me know. I'll try to get back to you guys as soon as possible. I'm not sure when that'll be after my eye surgery. And then finally, how prepared do you think you are for this test? 4 is you guys are most certainly going to get a high A or 100%. Okay, 3, definitely an A or a B. 2, cutting it close with the C or D. And 1, I'm probably going to fail this. Okay, if you guys are in this 2 or 1, you guys need to be going back, doing some work, whether that's adding notes into your OneBook, your OneNote, getting help, reviewing other assignments, doing assignments you haven't done yet, whatever the case may be. And then make sure you guys check through every slide on this PowerPoint to see if there's any extra little help for you guys. I hope you're all having a great day, and I'll talk to you soon.